If you're a Node developer, you've probably heard the golden rule, don't block the event loop, run asynchronous code. But depending on your skill level, you might be asking yourself, but what exactly does that mean? Asynchronous versus synchronous, or how exactly does the event loop work? Well, in today's video, I'm going to give you a very simple overview of the event loop, and then I'm going to go through 5 asynchronous functions that you can use in your code in order to work with the event loop. We're going to see these functions live using demos that I've already prepared for us, and afterwards I'm going to give a couple of great tips on how to write good performant Node applications moving forward. So let's get started. Now, before we get into the core of this video, there's a couple of points that I just want to make sure everyone understands. The first one is that on launch of your app, Node creates a single thread. So you've heard the term that Node is single threaded. This is what happens. For every app, Node creates a single thread, and that leads us to point 2, that inside that thread, an event loop is initialized. So this happens by default. One app, one single thread, one event loop. There are ways to turn your app into a multi-threaded application, but it's outside the scope of this tutorial and will be discussed later on. For the purposes of today, we just focus on a single app, single thread, single event loop. The next one is that your root code executes before the event loop runs. All right, so what does that mean? Let's say that your app starts at app.js or server.js. Inside there, you've got a whole bunch of code that you need to execute, and inside that code, you've got timeouts and all kinds of asynchronous functions that also run. At first, when your app launches, the core of that, the synchronous logic, will run first. And if you're requiring modules inside that app.js, those modules, synchronous logic, and the modules they require, and so on and so forth, all of that gets executed first to completion before the event loop comes into play, and only then is everything that's callback related, in other words, everything that occurs as a result of an asynchronous function gets managed in the event loop. So I hope that makes a little bit of sense. Each cycle in the event loop is referred to as a tick. So I might be calling a cycle a tick later on, and I just want you to know that we can use the names interchangeably. And for every cycle, there are multiple phases. So every time the event loop goes through a cycle, there are multiple phases within that cycle or tick that we need to be very aware of and that we will be discussing shortly. But first, let's take a look at these 5 asynchronous functions. The first 2 asynchronous functions you should be quite familiar with because they also get used as web APIs on the browser environments, and that is set timeout and set interval. Alright, I'm not going to go into details of how these 2 work. I'm going to make the assumption you know how they work. But you can use them in node.js to execute code asynchronously, and they are very, very important. Well, set timeout more important than set interval, depending on your requirement, of course. But the third and fourth one are actually only relevant to Node.js, and that is set immediate and process.next tick. Notice that you can actually just pass a callback function. They do have other optional parameters that you can work with, but for the most part, you'll actually just pass a callback function, and there's no delay or interval that's also required for these. The fifth one is the promise, okay? It looks a little bit more complicated, but essentially, once the promise resolves, it can execute your callback logic. So those are the 5 asynchronous functions that we are going to work with in today's demonstrations. And now the next question is, why 5? Or how do these 5 work? I mean, why not just have one, which is like set immediate? Why do we have next tick or promise? And that is going to be explained shortly. So what we're going to do now is we're going to move over to the event loop itself and understand these phases that make up an event loop cycle. So welcome to a very simplified overview of the event loop in action. And what we have over here is this is where our application will start. So this is your first file that it will be initiated for your Node app, which could be app.js or index.js. And as mentioned before, your root logic will be run synchronously first before the event loop comes into play. And only once the root logic is done over here will we kick off with the event loop itself. So we've got 5 phases over here. And the truth is there are more phases, but they are more relevant, they're more internal to Node. It's not really relevant to us. I'm only going to focus on these 5 for now. So the first phase is the timers phase. And this is where callback logic will be executed that was passed to a set timeout or set immediate function. Or, excuse me, set timeout or set interval function. So if I had a set timeout that was expired, that needed to expire in 5 seconds, and once expired, then I'm going to execute a whole bunch of logic. The event loop will run, and once that timeout expires, it will be caught in phase 1, and that callback logic will be executed. All right, so the same applies to set intervals. So that all happens in the timers phase. The second phase is I/O. It's more operating system level callbacks that are being executed over there. It's a bit of a confusing phase, and everyone has sort of a different version of this. But all we care about right now is that things like FS module and networking and encryption, callback logic occurs in this phase. It's not really relevant to the functions we've spoken about, except for 2, which I will get back to in a little while. That's why I've got this phase here. So we'll get back to that shortly. The third phase, probably one of the more important phases, is the polling phase. This is where new incoming requests are handled. So let's say that you've got a Node app, and using Express to expose a number of endpoints as REST APIs. When users consume those APIs, those requests are queued over here, so they get handled in the polling phase, and that callback logic is then executed for each of those requests coming in. So it's a very, very important phase over here. However, you'll notice I didn't mention anything about whether set timeout immediate or any of these occur over here. There are 2 asynchronous functions similar to the I/O logic phase, okay, which I'll get to in a shortly. We're getting there. All right, phase 4 is the check phase. Now this is where set immediate is handled. Okay, so if set timeout and set interval is handled in phase 1, set immediate is handled in phase 4. So if I had a set immediate function that I passed callback logic to, once we reach phase 4, event loop sees that set immediate and it will execute that callback logic. All right, so that's where set immediate exists. The fifth and final one is the close phase. This is where close events are handled. So if you have like a WebSocket on close, or if you have a this on close, or if you have a process.exit, the callback logic for those functions will be executed in this fifth phase now. All right. So we've found out where set timeout and set interval are handled. We found out where set immediate is handled. So the question is, where do process.nextTick and promises get handled? All right. And that's why I've got these other 3 phases over here. It's because process.nextTick and promises are considered microtasks to the event loop. Microtask as opposed to macrotasks. Okay. So what does that mean? It means that they are actually managed and executed at every phase of the event loop. And the best way to explain this is as follows. If I've got, let's say in phase 1, a set timeout, and inside that set timeout, I run a process.nextTick. All right? What happens is that process.nextTick will be queued as the next immediate asynchronous function to be triggered. So before any other timeouts get executed in that phase 1, it will first execute that next tick, or it will first execute that promise before it moves over to the next timeout. All right, so it's a microtask that sort of slips in between the separate timeouts that might need to be executed, and it also prevents the event loop from moving to the next phase until all process next ticks and all promises are resolved. Okay, very, very important. Now, it doesn't only occur in the timeout phase, it occurs in all the phases. So when we get to phase 2 or phase 3, guess what? It will go through the callback events of those phases, and if there are any next ticks or promises, those will get slipped in as the immediate next tasks to be executed. All right, so I hope I'm painting a picture over here, but we'll see this shortly in the live demos. So those are microtasks as opposed to the set timeouts, the set intervals, and the set immediate. So that's the differences between those 5 asynchronous functions. Now let's go and see this all in action so that we can get a good picture of how this is working how this would work in the real world. Right, welcome back everyone. So I've got a little bit of a application running over here, very, very simple. It's just a couple of JavaScript files, but what we're going to do over here is we're going to run each one of these and we're going to see these asynchronous functions in action. It's going to paint a clear picture over here. So let's get started with these. The first one is very simple. All I'm doing over here is I'm running some root logic, and I have a set timeout that will expire in 10 milliseconds. And what this test is going to show us is how the core root logic gets executed first, and only then does the event loop come into play to execute the asynchronous functions. So if I run node 1, we can see by the console logs that we have root code start, root code end, event loop takes over, and there's our timeout. So that confirms that even though we had set timeout before this console log, it was executed afterwards because this is an asynchronous function and we know that synchronous logic gets executed first. All right. So let's take a look at test 2 where we introduce set immediate. Now we've got over here, so we first initiate the set timeout, then we initiate the set immediate. We've got another set timeout of which inside will be a third timeout and immediate. And then finally we've got our root logic here to end. So I want you to take a moment, pause the video now, and see if you can guess in what order these are going to be printed out to the console. Alright, so I've given you a moment. Let's go and see what's happening over here. Node 2, and let's see. So we've got our root code. We're now happy that our root code gets executed first. But notice what happened. Look at immediate got executed before the 2 timeouts. But wait a minute. If we go back to this diagram, we can see that timers is the first inside, the first as part of a cycle. So why did immediate, which only occurs here in phase 4, get executed before timers in phase 1? Well, the answer is the event loop spins so fast, that loop happens so quickly, that by the time the event loop came into play, those timers, these set timeouts are set to expire in 10 milliseconds. By the time that the event loop came into play, those timeouts hadn't expired yet, which means what got hit first? The immediate. Okay, so the immediate got hit first, and then only did the 2 timeouts get hit afterwards, and that's why we've got the console logs like this. And then we've got the immediate 2 and the timeout 3 over here. So we can see that we set timeout again 10 milliseconds later, so the immediate would get triggered first. Now I'm sure by now I want to touch on something interesting. Can we set the timeout to 0 milliseconds? And the answer is yes, we can. We can actually set the timeout to expire at 0 milliseconds. But there's one small thing you need to be aware of, and let's see this in action. So I'm going to go here and I'm going to say run this please. And when I hit this, look at what runs first still. Okay? And this is the problem now. Because if we set timeout to 0, then surely it should have expired first by the time the event loop came into play, and therefore be triggered first. But why is immediate still triggering? Well, let me run this again. Okay, look what happened now. Suddenly it changed. Now timeout 1 came in first, and immediate came second, and timeout 2 came second. But that still doesn't make sense. We wanted the 2 timeouts to occur first. So let's see if we can run it again to actually get it happen that way. There we go. So it's actually, usually this is random, but it's working in my favor today. But we can see, okay, here we go. Now the 2 timeouts occurred as they should have, and only then afterwards would the immediate come into play. So why is this randomly changing? And the truth is, I can't really tell you, or all I can tell you is that it happens when the event loop comes into play, but after that, then it's pretty accurate. So what I'm saying is, between your node app starting and the event loop coming into play, it almost feels as if those timeouts are not initialized yet by the time the event loop starts, and therefore it hits the immediate, and only then does it see that there's 2 expired timeouts. But it's random. Okay. But what I do know is once that cycle has occurred, then, and you run further timeouts that are expired at 0, they will occur before the immediates. I do know that. So it's just this one part when your node app initializes and the event loop comes into play. So I hope that makes sense. I needed to bring that to everyone's attention. Let's go into our third test over here, and here we bring in the next tick. Okay, so you can see over here, I've got console logs, I've got the timeouts as before, but I've got process.nextTick over here. So again, take a pause now and see if you can guess in what order these console logs are going to be written to the console. All right, let's go. Once again, we're happy with our root code. But check here, nextTick came into effect immediately. All right, only then did immediate come in and everything else as we would expect it to come in. So how did nextTick get executed first? And if we take a look at the diagram, we would have expected that a next tick or something would have occurred only when the first timeout would be triggered. Okay, so where it almost feels like next ticks or microtasks are being executed here before it even reaches the timer phase. And the truth is that is actually what's happening, is that by the time it gets to phase 1, the first thing it does is it says, do I have next ticks or microtasks to process? Yes, I do. Okay, let's process those tasks. And then, do I have timeouts? Do I have intervals? Okay, let's work. First timeout. Do I have any microtasks? Okay, so it executes the logic of the synchronous logic of the timeout, processes the microtasks, moves to the next timeout, and so on and so forth. All right, so this is why the next tick occurred first over here. It's because microtasks happen everywhere. All right, it's a bit tricky, but bear with me. We will do a couple of tests. And if I comment this code out and I uncomment this code, you'll notice here, here's the first next tick, and inside it, I'm going to run another next tick. And what this shows us is that even if we're triggering a next tick within an asynchronous next tick, they will all still get executed first before it moves on to any macro task like a set timeout or set immediate. So if I clear the console over here and I run node, we're on the third one, eh? So you see over here, next tick 1, next tick 2, and only then does it start working through the rest of the tasks. So very important to understand microtasks. And the final example over here is where we bring in a promise. So you'll see I've got a promise before the next tick here at the bottom, and I've also got a promise running over here inside the set timeout. So once again, pause and see if you can guess in what order these are going to run. All right, so I don't know if you've paused, but welcome back. And by the way, if you're enjoying this video, do me a favor, will you give it a like? And if you want to see more content like this, please be sure to subscribe to my YouTube channel. I would really, really appreciate it. So let's run this. And we're going to do this task, and let's see what happens. Okay, next tick ran first. We expected that. Promise ran second. Okay, now we know, I said earlier on, we know that promises and next ticks are considered microtasks. They will get executed as microtasks. But what's important over here is that a next tick is prioritized over a promise. So it will first run all next ticks, and only then will it execute promises, and only then will it move on to the next macro task or next phase of the event loop. Okay, so I needed to bring that to everyone's attentions. Resolve promises and next ticks are microtasks. They're treated the same way, except that next ticks are triggered first and then promises are triggered afterwards. So welcome to the last phase of this video, and yeah, I just want to discuss a couple of tips that will empower you to write great performing Node applications. The first tip is requiring modules is synchronous. Execute at root level. Synchronous, it will block the event loop depending on the size of the module, depending on the core logic that it will need to execute. It's highly recommended that you actually require these modules on start of your Node application. Hoist them to the top of your file so that they get required on start. Okay, there's two reasons. Number one, again, it's synchronous, so it will block the event loop. But more importantly, it would be great to know that when your app starts, all your required modules are resolved. That's not something you want to figure out later on because it's wrapped inside a function. So it serves two purposes, and it's highly recommended. The second one, JSON.parse, JSON.stringify, console.log, they are synchronous tasks and can become expensive depending on the size of the content that's passed to them. I would avoid using JSON.parse and stringify as best as possible. Don't just use it because you can. Try your best to use it as little as possible, and if you need to, maybe wrap it inside a set timeout so that it gets executed after the polling, or maybe use some module like JSON stream or something along those lines, which will stream the JSON parse or the JSON stringify, keeping the event loop running. All right, and console logs are a lot smaller compared to the JSON parse and stringify, but it is a synchronous task. And depending on how many depending on how many log outputs you are throwing to your console, it can become expensive and cause problems for the event loop. So please be aware of those. Number 3, it is recommended that you use set immediate and set timeout instead of next tick instead of next tick or promise. Now, what I mean by this is, yes, of course, a promise has its purpose and you'll use it the way you need to use it. But what you need to remember, and I'm just going to jump back to this event loop diagram over here, is that if you use next tick as an example for everything, and you think to yourself, okay, but that's good enough, it's asynchronous code. Well, the truth is, if it's been executed here in the timers or the I/O phase, you're still blocking incoming requests. Okay, so even though you're pushing it to a promise or a next tick, it gets executed immediately, and it could still block incoming requests. And that's a big problem. This is actually what they're referring to when you block the event loop, because a lot of the blocking can occur here. If you use set timeout or set immediate, those transactions occur after the polling request for that cycle of the event loop. So it's a much better practice to say, okay, I can spare the extra 5 milliseconds and rather execute this logic as part of a set immediate or set timeout, because then it occurs after the polling, which means incoming requests can get handled, making your application a lot more efficient and responsive. Right. Next one. Move heavy-duty tasks to child processes or worker threads. In the beginning, I mentioned that you can actually turn your app into a multi-threaded application. You do that by clustering your node application using child processes or using worker threads. Okay, it's a little bit more technical, but it is possible. And heavy-duty tasks like looping and heavy data manipulation from large data sets that you might get back from data stores, I would highly recommend moving them to a sub-process so that they work in their own thread and they do not block the primary thread and the primary event loop that is running. Okay, I will be working on tutorials for these as well. So please, again, if you haven't yet, subscribe to my channel and stay tuned for a lot more. The final one, and it kind of works hand in hand with the tip number 3, the polling phase must take priority. Now, what do I mean by that? I mean, number 1, use set immediate and set timeout, as we explained in tip number 3. But the second one is you might want to be able to write an API that can be consumed and a response is sent within 10 milliseconds, which is wonderful. But at the cost of what? Is at the cost of 100 concurrent incoming requests being blocked until those APIs are consumed and delivered. So, and I think that's what I'm trying to say over here is prioritize the polling phase. Make sure that there's no blockage of incoming requests. I'd rather have an API that takes 15 milliseconds to run versus 10 and know that I can bring in 10 new connections concurrently. Prioritize the polling phase, please. Use set immediate, use set timeout whenever you can so that you can keep that event loop cycling. Well, that's it, everyone. That's the end of our tutorial. Quite a lot, but I really hope that everyone enjoyed it. And really, if you have, do me a favor and just send me a like on YouTube. And if you want, subscribe to my channel. It really makes a big difference. The more followers that I get, it just inspires me to commit to a lot more of these kind of tutorials. And until next time, cheers.